Hello everyone. In this second motivating scenario for ARC, our assistant for repetitive code comprehension, I will be an instructor for an introductory Java course who needs to grade 35 students' programs for a particular assignment. In an introductory Java course, it is not sufficient to just try compiling the student's code and running it against a set of test cases, because beginner students need more personalized forms of feedback. Therefore, I have to look at their code, understand it by maybe searching for specific code snippets and creating a mental trace of each one of them so that I can provide the feedback. There is going to be a lot of comprehension of repetitive code involved in this activity, and that's where ARC is going to be helpful. So the assignment has the following description. Write a static method that checks whether a given integer is a palindrome. The method must return a boolean, either true or false, and must not use any string functionality. So for instance, the number 15651, it is a palindrome because if you reverse the digits, you get the same number. So the method should return true. However, the number 2565, it is not a palindrome. If you reverse the digits, you get a different number. So that should return false. So I've copied all 35 submissions from students into Eclipse, and I'll go ahead and open the first one. As a former Java instructor myself, I think it's convenient to start with the good students, because their programs are usually correct and easy to grade. Let's assume this is one of those submissions from the good students. So I take a couple of minutes to check the submitted method, see if it looks good, and then if it does, I use it as a reference method to generate a strategy from it. I'm going to go ahead and right-click on the method from the Package Explorer and say create strategy. So ARC immediately found these patterns in the selected method. So I'm going to go ahead and create a strategy that includes all of these patterns. And that's it. Let's name it assignment 3 strategy 1. And I'm going to give all these patterns the same color because sometimes we just want to highlight the whole strategy and maybe we're not interested in knowing which specific statements in the program relate to a specific pattern. And click OK. And the strategy is created. Now we can go ahead and search for that strategy that we just created. So we do Ctrl H, go to strategy search, and select the strategy that we created, which is that one, and search. We have the option of running the search in the background, but it's not going to take a long time. And it's done. So the tool found 12 programs which implement the same strategy. That means these solutions, these 12 out of 35 solutions, are semantically equivalent. That's actually very common in introductory programming assignments, and it doesn't necessarily mean that some students have copied from each other, because semantically equivalent doesn't mean they are exact clones. Let's take a look at solution number 4. So this solution here has, it's implementing the same strategy as solution number 1, right? However, it's got a weird looking but still valid for loop. Solution number 1 has a while loop. Let's take a look at the next submission. This one here also uses a while loop, like number 1. But the statements are in a different order. See, this variable length is being assigned to that expression. Some variables also have a different naming. Okay. And even though they are semantically equivalent, they are not exact copies. And this is very common in introductory programming courses. Now let's take a look at some of the submissions that are not in this group, like solution number 3. I can see that it's very different from the ones that we were looking at. It's got 2 loops and it's got other things. So I'm going to go ahead and generate a strategy from it. create strategy. Let's give it a name. Assignment 3 strategy 2. And I'm going to include all the patterns that were found in the reference method. And also I'm going to give it the same color to every pattern. Now that this strategy has been created, I can do Control H once again, strategy search. This is the one we just created, and search. Okay, it's done. So only 2 students used that strategy. If I look at it, I may realize as an instructor that this is a very uncommon way to determine whether a given integer is a palindrome. So it is possible, it is not impossible, that these 2 students may have plagiarized the code. Let's create a new strategy with solution number 2. Create strategy. And again, I'm going to include all the patterns that were found by ARC in this reference method. Only 2, strange. So assignment 3 strategy 3. Going to give the patterns the same color. Okay. Now I'm going to search for that strategy. There are many programs here in this package, so that is why ARC is taking a few seconds. And it's done. It found 7 programs that are similar to solution number 2. Let's take a look at them. Well, this is solution number 2 itself. This is solution number 5 here. See, they are not exact copies, but they are semantically equivalent. So why is this helpful? Why are we doing this? With the help of ARC, I can grade the student submissions in bulks because even though every program is most likely different from the rest, they'll implement the same handful of strategies, semantically speaking. In this video, we didn't emphasize the purpose of the highlighting, but ideally, the highlighting feature will help me identify where the relevant snippets are in the student's code. This, I think it's a good advantage, and if part of your job is grading code for an introductory Java course, I would say download the ARC plugin from the link in the description and let us know what you think.